Alright, I mentioned in our last video that this was what was coming next, and here it is. It's the quadratic equation. I am going from memory here, but I am almost certain, 99% certain, that the quadratic formula is just derived from completing the square. If you left, I'm sure this is true, if you left this in a generic form with a, b, and c as your numbers instead of real numbers, you left these variables, and you completed the square and you solved it, you get this equation here. So in other words, you are completing the square. This is just true for any numbers you would want. And so we can just go through and replace a, b, and c with whatever the numbers are in my actual equation. And it's just like you completed the square, and you'll always get a solution here. Now, this is, I don't know how in depth we're going here. Well, we've talked about complex numbers already, so we can get some complex solutions as that involve imaginary numbers, but we'll talk more about that. So let's get going here. First of all, here's how we use the quadratic. So in front of the x squared is a 1. So that's my a, my b is 5, my c is 1. And all I have to do is plug them in. So negative b, let me put it here again just in case, plus or minus the square root of b squared minus 4ac all over 2a. Now, most professors, most teachers would expect this to be memorized because it's so useful. So I would expect the same here just because it comes up so much in higher math. So I'm just plugging in, crunching down. Now be careful of the order of operations. Remember, you'd have to do inside any grouping symbol. A square root works as a grouping symbol. So clean up in there. You do the exponents inside of there first. So you're tidying all that up. You're going to get this. Now, this is really two solutions. This is negative 5, then you'd add the square root of 21, divide by 2. You'd take negative 5, subtract the square root of 21, and then divide by 2. So those really are two individual numbers. So let's try one again here. I guess we're going to use theirs again. So we've got a is going to be 1, b is going to be 1, and c is going to be 2. Now, you could always try. Factoring is much faster than all of this, but the beauty of the quadratic formula is that the quadratic equation, technically I should say quadratic formula. The beauty of the quadratic formula is that it will always get you the answers. So if you see a quick factoring solution, that's great, but this will always get you there. That's why completing the square, I think, it will get you there too. Maybe you find that to be easy. Most students don't. So that's why most people would just go right to the quadratic formula. But okay, so I've got my a, b, and my c. I'm plugging them in, working my way through that, cleaning up under the house. Now look what happened here. I've got the square root of negative 7. Well, this is an imaginary number. So let me see how so they do it like this. So they've turned that, remember, that means the square root of 7 times the square root of negative 1. That's what it means. And although this is really, we call it I, but it's just an abbreviation to tell us that this is an imaginary number. Just helps simplify the work. So we're calling this an I. We've taken the square root of negative 1 and turned it into an I. So we have two complex solutions where you'd have negative 1 plus this imaginary number divided by 2, negative 1 minus that imaginary number. So two complex solutions. Okay, so pause this if you want to try this on your own. So I'm going to write the quadratic over here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b plus or minus the square root b squared. Another thing that students will have some trouble with sometimes is this. Be careful of your signs. Like if you're squaring a negative number, if b was a negative, the negative is getting squared as well. So just be careful. Okay, so let's start cleaning up. So this is 9. So be careful of that sign too. I've got 4 and 2 here, so I've got 8. So minus 72. All of that is going to be over 18. So what do I have here? Negative 63 Okay, now this is the best I can do, but I've got this imaginary number, so I'm going to just indicate that. So I turned the negative under there into I. Let's see. Yeah, there is some simplifying you could do here. I guess I'll go ahead and show that. So remember, we can break down 63 and we could bring some of it out. So 63 is going to be 7 times 9. Now this can go further and we get 3 times 3. So the square root of 63 is really the same as 7 times 3 times 3. All right, now inside of a square root, it takes two of a kind to bring something out. So here's what I'm getting at. Okay. Now there's a couple ways you could think of this, but this could be simplified a bit further. These are two separate terms up at the top, but you could factor a 3 out of there. And so I want you to think of it like this. See, they're two separate terms, but I can take a 3. So like a square root works like an I don't know, like a variable. But I could factor a 3 out of there. So I'd have this. Well, I'm going to turn this into here so you can see what I'm doing. You wouldn't have to show all these steps. I just want you to see what's going on. 18 is 3 times 6. So those could cancel down. And my final answer, now I'm not sure if I would require all of that reducing there, but it's good that you understand. Oh, I left out an I, didn't I? Sorry, I lost an I all the way back here. I'm going to put them on the back just right there. So I forgot we did the I, so I need an I in there as well. Okay, now this portion that's underneath that root is called the discriminant. And you can know some things about your possible solutions just by taking a look at just the value of the discriminant. And if you think about this, well, where is this coming from? It's really just logic. Let's jump to one here. So on each of these, they've just found the value of the discriminant. Okay, so I've got the whole quadratic equation here. Well, why is the discriminant telling me interesting things? Well, if you found the value of the discriminant, they found out it's 0. Okay, well, if this turns out to be 0, all you'd have left is negative b over 2a. You're going to get one value. There's just going to be one answer because we dropped the plus or minus. Do you see what I'm saying? Because the square root turned out to be 0, we no longer need the plus or minus, and so we're just going to get a single solution. Okay? It's not going to be plus or minus, it's just the one single number. Okay, now on this one, they worked it and they got 100. Okay, well, what's that going to tell us? Well, if we got 100, then this square root is going to be a nice integer. We're going to get negative b plus or minus, for instance, in this one, 10 over 2a. Well, this is going to get us two rational solutions. We're going to take negative b, we're going to add 10 to it. We're going to take negative b, we're going to subtract 10 to it. But these are two rational numbers because we're going to have two of them because we're adding and subtracting. Now, oh, they've done it again. Yeah, same thing here. If I got 49, I'd have this 49 underneath the square root. Well, if I square rooted that, I'm going to get another integer here, so I'd have two rational solutions. I'm adding the 7, I'm subtracting the 7. Now, I'm hoping they're going to do, yeah, okay. Now, on this last one, our discriminant, this portion underneath the root, turns out to be a negative number. Well, do you see where this is going? If I had had a negative number underneath there, and I'm adding, subtracting, this is two complex numbers. We'd have to deal with the I stuff. So I'd have plus or minus two numbers that involve I, so there'd be two complex solutions. So what we're saying here is if you get 0, you're going to get one solution. And I don't know if I want to talk about this here. It's a double solution. It repeats itself. But so you get one solution twice. If you get a perfect square inside of there, you're going to get two rational solutions because of the plus or minus, and we got a nice square root. Here again we got a perfect square, so we'd get two rational solutions. And then finally we got a number that was a negative for a discriminant, and so that would have to be two complex numbers. Now, I've never put a lot of weight on the discriminant because it's pretty much just logic. You could have just done the whole thing and figured it out as well, but so books will mention that. So again, you've probably seen the discriminant before too. Okay, now this kind of seems out of place here, but I guess it's because it creates quadratic situations. What we're just doing here is we're asking to find a missing side of a right triangle. Well, that's the Pythagorean theorem. If you remember, it's a squared plus b squared equals c squared. So again, I think this is here because it's creating squares. Okay, so if I just tidy this up and start to solve it, I'm going to get a squared equals 128. Now, we can use that square root principle that we saw earlier in the last section, or in the first video on this, where we can just square root both sides. Now, here's another case again where they're not doing the plus or minus. So I thought we were supposed to do plus or minus whenever we took a square root in this section. Well, we are technically, but if you think about this, if these are lengths of a side, you can't get a negative length. So that's why they just ignored it. They simplified that root using those tricks I showed you earlier in this section, and they get down to our answer. Okay, so we're going to try this again. Okay, I'm like looking for what they gave us. All right, so what they're telling us here is that A is 4, B is 3, and we're looking for C this time. So, shoot. Sorry, I've messed up. Hold on, gotta get back to it. Okay, so I've got, I think I did this in a different order, but I've got my 2 sides squared equals c squared. So that's 9 plus 16 equals c squared. 25 equals c squared. So if we square root both of these sides, I'm going to get c as 5. Now technically it's plus or minus 5, but I can't have a negative length. And there's my solution. Okay, so the quadratic equation is the key to this section. Remember, it can always find a solution to a quadratic problem. It might involve some complex numbers, but that's fine. So it's a little slower than factoring and some other approaches, but it'll always get you where you want to go.